Have you ever stopped to think about the hidden science that's literally all around us? I mean, from the food on your plate to the very air you're breathing right now, everything is a wild, fascinating mix of different things. Today, we're going to pull back the curtain and explore the science of mixtures. All right, let's dive in. Take a look at this scene. You've got trees, a soccer ball, stairs, people, all sorts of stuff, right? Well, in the world of science, all of this stuff goes by one simple name, matter. And it is, no exaggeration, absolutely everywhere. But, that just leads to an even bigger, more interesting question. If everything we see and touch is matter, then what is all this matter actually made of? Let's break it down. To get started, let's look at something we can all relate to, something we interact with every single day, the food that we eat. So whether you're looking at a delicious plate of poha or a super healthy sprout salad, these dishes have something really important in common. They're both made by just, combining a bunch of different ingredients. And in science, that's what we call a mixture. Now, here's the really crucial part about mixtures. The individual ingredients, they don't magically transform into something brand new. The onion in that salad is still an onion, and the tomato is still a tomato. They're basically just hanging out in the same bowl without chemically changing each other. Okay, but as you've probably already guessed, not all mixtures are the same. Some are super obvious and easy to spot, while others, they're kind of like masters of disguise. So let's go back to our sprout salad for a second. This is a perfect example of what we call a non-uniform mixture. It's called that because you can easily see all the different parts. The sprouts, the tomatoes, the onions, nothing's hiding. It's all right there. But what about this? Imagine we take a spoonful of sugar and stir it into this glass of water. Poof! It seems to just vanish. It's still in there for sure, but you can't see it anymore. This is a uniform mixture, where all the parts blend together so perfectly they become invisible to our eyes. So, let's just do a quick recap to make sure that sticks. In a non-uniform mixture, like our salad, you can see the different components, and they're spread out unevenly. But in a uniform mixture, like the sugar water, the components are totally invisible and spread out perfectly evenly. Simple as that. We've talked about mixtures you can eat, but what about the most common, most essential uniform mixture on the planet? Yeah, it's the one you're interacting with this very second, the air you breathe. That's right. The air all around us isn't just one thing. It's actually a uniform mixture of different gases. The vast majority of it, about 78%, is nitrogen. Then you have the oxygen we need to live. That's about 21%. And that last little 1%, that's a mix of a bunch of other gases, including carbon dioxide. This brings up a really fun question, though. If all these gases are completely invisible, how can we be so sure they're actually there? How in the world could you prove that something like carbon dioxide is floating all around us? Well, we can actually prove it with a really clever and simple experiment. First, you create this clear liquid called lime water. Next, you just pour that clear solution into a dish. And then, for the last step, you do nothing. You just leave it out, totally exposed to the open air. After a few hours, something pretty amazing happens. The totally clear liquid turns all cloudy and milky. Why? Because the invisible carbon dioxide from the air reacted with the lime water. That reaction creates tiny, white particles of something called calcium carbonate. It's literally visible proof of the invisible. And you know what? It's not just gases in the air. If you take a black sheet of paper and just leave it by an open window for a while, you'll pretty quickly find it's covered in all these tiny particles. This just goes to show that air is also a mixture that contains tiny solids, like dust, floating around. Okay, so we've looked at natural mixtures, but for centuries, we humans have been creating our own incredibly powerful uniform mixtures, the kind that have literally built the world we live in. I mean, just think about the utensils in your kitchen. That spoon, that pot, that jug. Chances are they're made of materials like stainless steel or brass. These are special kinds of uniform mixtures that we call alloys. So an alloy is basically a uniform mixture where at least one of the main ingredients is a metal. By mixing metals together, like copper and zinc to make brass, or copper and tin to make bronze, we can create totally new materials that are often way stronger or better for a specific job. And get this is not a new idea, not even close. In fact, ancient Indian texts talked about alloys, calling them mishraloha, which means mixed metals.
They even believed that bronze, which they called kamsia, had medicinal uses, like helping with digestion. How cool is that? It's this amazing link between ancient wisdom and modern science.
All right, we have talked a lot about mixtures, but this brings us to one last really important question. I mean, we see the word pure on labels for milk or spices all the time. But after everything we've just learned, what does that word really mean? You see, in our everyday lives, pure might just mean natural or it doesn't have any weird stuff added. But in science, the definition is super specific. A pure substance is actually the exact opposite of a mixture. It's something that's made of only one single type of particle, not a jumble of different things. So, I'll leave you with a little thought experiment. The next time you're shopping and you see a label that says pure on it, just pause for a second and think. From a scientific point of view, is that milk or that juice or that honey truly a pure substance? Or is it a really, really well-marketed